Yay, shaky cam video time. So I brought, this is part 2 to the edge LED sign. I brought my G-code out on a memory stick, copied it to the computer, took the memory stick out. You never want to run the G-code from the memory stick. Found that it's too slow. I'm using Mach 3, but never do it. So I've got my file loaded up. Actually, I got the outside profile, so we can see here that this is the outside profile it's going to cut, so it will not cut anything bigger than that. Got my piece of material just thrown down there. Now I got to see if it's going to fit. And spoiler alert, I know it's not. So what we're going to do is I've homed the machine. It's sitting at the home switches. This is a really janky setup, I know, but this is what I have to do because I'm limited in space. But and one thing I didn't show on the creation of the toolpath and the CAD software is after I got done making the video, I went in and recentered everything so my 0 point is in true center. So it's the same distance from here to here and from here to here. Before it was down a little bit the way I drew it up. Anyway, so I need to find my 0 points. My 0 point should be somewhere in here. But what we're going to do is we're going to jog. So I have my keyboard situated this way. I'm standing on the side, but the machine operates this way. So this is Y axis, this is X, and Z of course is down. So with the keyboard set up in the same orientation, which I can actually just bring this down here. If I press the down arrow button, my spindle comes this way. Right arrow button, my spindle goes that way. So what we're going to do, I'm going to hold the shift button down to put it in rapid feed rate mode. We're going to come down and over, and let's just bring the spindle close. So if I want to leave that minimal amount of space like I do on all of them, what I can do is I can come up here, and that's Y, so I'll 0 Y. You see the crosshairs come down here. Now if I jog, and this magenta crosshair, if I jog this till it goes outside here and I get a red line and re-zero, that's how far down the center of this will be. I'll show you here in just a second. So shift and holding the down button, get my fat fingers out of the way. Just until I get that red line. So I get that red line and I 0 again. That will be the center of my part from here to here. So now I'm going to jog X over, leave me a little gap. We're going to do the exact same thing. I'm going to 0 X. Now I'm going to jog over the other way until this crosshairs comes outside of this blue line and I get the red line. So I get the red line, I'll 0 X again. So theoretically, that's the center of the part. Now what I can do is I can jog the machine and see if the tool is going to go in features I don't want it to go in. So basically seeing if I can make this part fit in this much material. So if we jog all the way over again, so it will not go past that. And if we look, we can see we're already outside or inside where this cutout is. And if I jog down, so right about here's where, when it's doing the profile, it'll come back around. We can see that the part I want will not fit in this piece of material. My options: go back in, resize it, recreate the toolpath to make it fit. But if it's something that I want to be that size, page up. Since we know where 0, 0 is because we've centered them, or we've zeroed them, we move this out of the way. Take this out. I've already got a new piece of material. I already pulled the paper off because I want it to be that size. There's a reason why I want it to be that size. So I have a brand new piece of material. I know the part's going to fit. So all I have to do is fasten it down with what these washers will do. Put that screw in, tighten those up, and I have to change the bit, and I'm going to load my other G-code, which will be the quick engrave. So I've got to put this collet with this spring-loaded tool. That's what I'm going to use to engrave it. So I'm going to pause this, and it'll be just a second for you. Collet and tools are changed, so now I'm going to jog over closer to me and come down, and I got to set my Z-axis height, my Z0. So I have a 0.457 millimeter thick shim, and this is acrylic, so it's very easy to get scratched, and I've just realized I forgot to tighten all these screws down, so let's do that real quick. I'm going to lay that under that so I can find it. Push my material up into this corner of my fixture. So this pocket is just a little shallower than the material is thick, so these washers go up at a ramp to help push pressure down and hold it in place. Let's jog this up out of the way. Shaky cam for the win, but I don't care. My videos are quick, dirty, and to the point. Alright, let's jog this guy back over to our shim. And when I'm using the spring-loaded drag engraver, I come down, and I come down to where I just get a little bit of pressure. I can see it pushing down or the bit pushing up. I know that that shim is 0.457 millimeters thick. So instead of zeroing Z here, I'm just going to click on my field and I'm going to type in where it's at, 0.457, press enter. So now it effectively knows where Z0 is because I told it where it was at in space. Now granted, someone's going to balk and say, yeah, but you put a little bit of pressure, it's not going through the material, so it's not going to matter. Raise it up. Take this out and push go. It's basically all I have to do. So if I press cycle start, my spindle turns on the VFD for the power. I don't press run, so it's not spinning. And here we can see it's doing its thing. I'll pause this, let it get into the engraving a little further, and hopefully pick up this video. If not, I'll have to put them together to upload them. So if you watched all of the machining videos, little snippets, I'm doing that basically just so my phone doesn't stop the video so I can make it all in one. But the keen item on you will notice that when it was doing the engraving part, going around the letters first, it did 2 passes. And now it is going in and doing the hatch, and it's doing 2 passes. And the reason it's doing that is because I specified a depth of cut of 30 thou, which was deeper than what I told the tool in my tool settings it was allowed to go per pass. That way I get really nice deep scratches in this. So all the outlines get actually essentially 4 passes and the hatches get 2. So this is almost done. It's just got this line to go over again, and then the rest of the letters, and then we'll do the outside profile. Alright, so we are done with that. If we look here, took us just under an hour. And if we look, we can see that, yes, this is Mach 3. This is just a screen set I had a hand in helping develop. But it's running the regular Mach 3 underneath it. So now what we're going to do is we're going to load the profile toolpath. And now I get to put this collet and that tool in the spindle and set a Z0. So let me get that done real quick. Alright, so that is in. I'm going to grab my air hose, give this a quick blow off. We're going to do the exact same thing as before. Put my feeler gauge down there, jog down. Now let me pause real quick because I need two hands for this. So what I'm going to do is I'm going to wiggle the feeler gauge back and forth, jog down until I get a resistance on the feeler gauge, and then go up there and tell Z that it is at 0.457 millimeters off the Z0. Alright, so now we can see here I can move the feeler gauge, but it has resistance. So we're just going to come up here, click on that, type in a 0.457, press enter. So we're telling it where it's at, so now I can jog straight up. Take my feeler gauge out, just gently slide it out. Now this is going to make a mess. So the way I've got my cabinet built here is this door that goes right here closes, and so does the front. I'm going to go ahead and turn the spindle on. Software will do it for me, but I have to manually push the button. So turn spindle on, relay clicks, gets power. Go over here, click run. So this spindle is 24,000 RPM spindle at 400 Hertz. So this is a Hertz reading. At 200 Hertz, it's 12,000. So it's just a little up above 12,000. So I'm going to close the door and press go. Alright, and then that door, then cycle start. That's a down cut single flute end mill. So it's pushing the material down into the machine. It's not trying to lift it up like a standard end mill would do. And when doing this, cutting acrylic like this, it smells like a nail salon if you've ever went in there where they do acrylic nails. But the chip load, as you can see, the idea is to not melt the material, but cut it. So there's my little back and forth as it steps down. Here's the end of the third pass. This should be the fourth pass. It's cut all the way through. There's one tab. There's two tabs. Another. There's another. And it's done. So let's go ahead and open this up. Let me grab my air hose. Now we're going to take it out, and we got a little bit of post-processing to do. So here I am sitting at my jewelry bench. We're going to post-process this. Sometimes if you don't get it to where it cuts all the way through, this thing just fell out. My tabs were so thin it held it in place while it was cutting, but we have remnants of some of them. And what I use, since I have a jewelry bench and some tools, I use these little sanding discs on the end of my Fordham. I'll just sit there and knock those down, polish all the way around it. You can use sandpaper wrapped around a stick, whatever. So I'm going to knock those out real quick. I'm going to blow it off, peel the backing, and we're done. So here we are, finished product. There's a couple things I have to do. I did nick it right there. No big deal. So we can see that it cut around the outside profile and went on my spoil board. So I will just take a piece of sandpaper the next time I do this, and I will just go around that just so there's no fuzzies sticking up, so the plexiglass will lay flat. There it is, all said and done. Hope it helps somebody.